Okay, so this is section 5.1, problem number 5. So we're dividing a fourth degree polynomial by a second degree polynomial. So we set this up as a long division. So the denominator or divisor goes on the outside of the long division setup, and the numerator goes on the inside. So it takes a little bit of writing because there's a lot of terms. There we go. And again, as if you watched the previous video, we want to make the first term on the outside become equal to the first term on the inside. So what do I always look at the first term versus first term? How do I make the 3, this outside first term, the 3 become equal to a 9? I have to multiply by positive 3. How do I make an x squared become an x to the fourth? I multiply by another x squared, because x squared times x squared gives you x to the fourth. Okay, so I compare first term to first term. Now, when I multiply this back down, I multiply all 3 terms. When I decide what to put here, I just look at the first terms. But then when I multiply back down, we multiply all the terms. So 3x squared times 3x squared is 9x to the fourth. 3x squared times negative x is negative 3, because 3 times the negative 1, think of that as a negative 1, right? A little secret negative 1 there. Okay, 3 times negative 1 is negative 3, x to the third, because the power goes up by 1. Right, x to the 2 times x to 1, you'd add the powers, becomes x cubed. I'm going to line it up underneath the other x cubed. And then 3x squared times negative 2 is negative 6x squared. And now the 9x to the fourth minus 3x cubed minus 6x squared, I've already accounted for that. The 3x squared together with this divisor on the outside together account for this. So this has already been taken care of. I don't want this in there anymore, so I subtract it out. Okay, we always subtract that product because it's already been accounted for. Okay, so 9x to the fourth, take away 9x to the fourth is 0. We expected that. Then negative 18x cubed plus 3x cubed, because minus on a minus is plus. Negative 18 plus 3 makes negative 15 of these x cubes. Negative 16 plus 6, right, because minus on a minus is plus, so negative 16 plus 6 makes negative 10x squared, and then the 20x has nothing to subtract from it, so we just leave it as 20x. We have nothing to subtract from the 7, so I just leave it as a 7. Okay, so now I say to myself, okay, how do I make the first term on the outside look like the first term on the inside? So how do I make a 3 look like a negative 15? I need a negative 5, right? I'm going to multiply by negative 5. Negative 5 times 3 gives you negative 15. How do I make an x squared look like an x cubed? I need another copy of x, because x times x squared gives you x cubed. Okay, so I look at the first term on the outside versus the new first term on the inside to decide what term to put in here into the quotient, into the result. But then when I multiply back down, I multiply all the terms. Negative 5x times 3x squared is negative 15x to the third. Negative 5x times negative 1x becomes positive 5x to the 2. And then negative 5x times negative 2 becomes plus 10x. And I'm going to subtract that because it's already been accounted for. Negative 15 of these guys plus 15 of these guys make 0. They're gone, 0 of them. Negative 10x squareds minus 5x squareds is negative 15 of those x squareds. And then 20x take away 10x is 10x. And then the 7 is still with us because there's nothing to affect the 7. Okay? So again, as long as the power of x is equal to or greater than what's on the outside, you can do another round of division. Okay, once you have fewer copies of x, fewer powers of x in your remainder, in this partial result, once the x here becomes lower than what you have on the outside on the divisor, then you're done. You can't go any further. Okay, but in this case I can go further because the powers are equal. So how do I make the outside first term look like this inside first term? I need a negative 5 because negative 5 times 3 gives you negative 15. And then when I multiply back down, I'm going to have negative 15x. Oh, I'm sorry. We don't need any more x's. Okay, sorry, somebody was at the door. Okay, so I've got, so 3x, so the negative 5, we're multiplying it back down. Negative 5 times 3x squared is negative 15x squared. Negative 5 times negative 1x is plus 5x's. And then negative 5 times negative 2 is plus 10. And we're going to subtract this because it's already been taken care of. It's been addressed. Right? The negative 5 together with this outside stuff, this divisor quantity with the negative 5 already accounts for this, so I'm going to subtract it away. So negative 15 of these x squareds plus 15 of them makes none of them. It's gone. 10 of these guys take away 5 makes 5 of them. Whoops, it's not letting me write at the bottom of the screen. That's happened sometimes. And then 7 of these guys, take away 10 of them. Well, it's just 7, the number 7, take away the number 10 is minus 3. Okay, so that's your remainder. I know I'm done because I just have power, I just have x to the 1 now. I can't divide x squared into x to the 1. It won't go. It's to have too much x on the outside. Okay, once the power of x becomes lower than what you have on the outside, you have to stop. That's it. You're done. That's your remainder. Okay, so this is your quotient. Okay, result, and that's your remainder. And there we go.